Artificial intelligence. The ability of a computer or computer-controlled robot to perform tasks commonly associated with intelligent beings. Human intelligence is the ability to learn from experience, adapt to new situations, understand and handle abstract concepts, and use knowledge to manipulate one's environment and include the ability to adapt to new circumstances. Human intelligence is not characterized by just one trait but by the combination of many diverse abilities. Since the development of computers, it has been demonstrated that they can be programmed to carry out very complex tasks, like discovering proofs for mathematical theorems or even playing chess, with great proficiency. If you have found this video useful, please like, share and subscribe for more videos and write your comments or questions. Artificial intelligence is the ability of a developing systems to perform tasks commonly associated with human beings and intellectual processes characteristic of humans, such as the ability to reason, discover meaning, generalize, or learn from past experience. Despite continuing advances in computer processing speed and memory capacity, there are no programs that can match full human flexibility over wider domains or in tasks requiring much everyday knowledge. On the other hand, some programs have attained the performance levels of human experts and professionals in performing certain specific tasks, so that artificial intelligence in this limited sense is found in applications as diverse as medical diagnosis, computer search engines, voice or handwriting recognition, and chatbots. Research in AI has focused on the components of intelligence which are learning, problem solving, reasoning, perception, and using language. Learning. There are many different forms of learning applied to artificial intelligence. The simplest is learning by trial and error. For example, a simple program for solving mate-in-one chess problems might try moves at random until mate is found. The program then stores the solution so that the next time it encountered the same position to recall the solution. This is a simple memorizing of individual items and procedures, known as rote learning, and it is relatively easy to implement. A more challenging form of learning is applying past experience to a similar new situation. For example, a program that learns the past tense of regular English verbs by rote will not be able to produce the past tense of a word such as jump unless it previously had been presented with jumped, whereas a program that is able to generalize can learn the add-ed rule and so form the past tense of jump based on experience with similar verbs. Problem solving, in artificial intelligence, is characterized as a systematic search through a range of possible actions to reach a predefined solution. Problem solving methods are divided into special and general purpose. A special purpose method is tailor-made for a particular problem and exploits very specific features of the situation in which the problem is embedded. On the other hand, a general purpose method is applicable to a wide variety of problems. One general-purpose technique used in AI is the incremental reduction of the difference between the current state and the final goal. The program selects actions from a list of means until the goal is reached. Many diverse problems have been solved by artificial intelligence programs. Some examples are finding the winning move in a board game and devising mathematical proofs. Automated reasoning is considered a subfield of artificial intelligence. To reason is to draw inferences appropriate to the situation. For example, Jane must be either at the restaurant or the pub. He is not in the pub, therefore, he is in the restaurant. Inferences are classified as either deductive or inductive. For example, previous accidents of this sort were caused by instrument failure, therefore, this accident was caused by instrument failure. A reasoning system is a software system that generates conclusions from available knowledge using logical techniques such as deduction and induction. The most significant difference between these forms of reasoning is that in the deductive case the truth of the premises guarantees the truth of the conclusion, whereas in the inductive case the truth of the premise lends support to the conclusion without giving absolute assurance. Inductive reasoning is common in science, where data are, and tentative models are developed to describe and predict future behavior, until the appearance of anomalous data forces the model to be revised. Deductive reasoning is common in mathematics and logic, where elaborate structures of irrefutable theorems are built up from a small set of basic axioms and rules. True reasoning is one of the hardest problems confronting AI. There has been considerable success in programming computers to draw inferences. However, true reasoning involves drawing inferences relevant to the solution of the task or situation. Perception. In perception, the environment is scanned by means of various sensors and the scene is decomposed into separate objects in various spatial relationships. It is a complicated analysis since an object is appear different depending on the angle from which it is viewed, the direction and intensity of illumination in the scene. At present, artificial perception is sufficiently advanced to enable optical sensors to identify individuals and autonomous vehicles to drive at moderate speeds on the open road. Language. A language is a system of signs having meaning by convention. In this sense, language need not be confined to the spoken word. It is distinctive of languages that linguistic units possess meaning by convention, and linguistic meaning is very different from what is called natural meaning, exemplified in statements such as "those clouds mean rain" and "the fall in pressure means the valve is malfunctioning." An important characteristic of human languages, in contrast to bird calls and traffic signs, is their productivity. A productive language can formulate an unlimited variety of sentences. Large language models like ChatGPT can respond fluently in a human language to questions and statements. Although such models do not actually understand language as humans do but merely select words that are more probable than others, they have reached the point where their command of a language is indistinguishable from that of a normal human. What, then, is involved in genuine understanding, if even a computer that uses language like a native human speaker is not acknowledged to understand? If you have found this video useful, please like, share and subscribe for more videos and write your comments or questions.